You believe this is the only universe. There's not just one universe. There's a multiverse.
We think, when I say we, just the scientific community, physicists who concern themselves with the very early universe, cosmologists, that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours, because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out sort of the same in the very first instant, a later instant when other laws of physics manifest could be slightly different.
The concept of infinite worlds is a very old idea discussed in the philosophy of ancient Greek atomism, which states that the physical world is composed of fundamental indivisible components known as atoms. Ancient philosophers proposed that infinite parallel worlds arose from the collision of atoms. In the 3rd century BC, philosopher Chrysippus suggested that the world eternally expired and regenerated, effectively suggesting the existence of multiple universes across time. However, the concept of multiple universes has reached maturity only in the time of modern physics. In Dublin in 1952, Erwin Schrödinger gave a lecture in which he warned his audience that what he was about to say might seem lunatic. He said that when his equations seemed to describe several different histories, these were not alternatives, but all really happened simultaneously. This sort of duality is called superposition, which is a hard concept to grasp in and of itself. And understandably so, our brains are not evolutionarily equipped to intuitively understand quantum mechanics and large-scale cosmic phenomena. But we'll give it a try anyway.
With the multiverse, where there could be pockets of the universe that are expanding with no knowledge of any other pockets of the universe. These are essentially independent universes from one another, and never the twain will meet. Imagine you're a ship at sea and you look to the horizon, and that's your whole universe there, to the horizon. There's another ship that has its own horizon, and these ships don't even see each other. You'll only see each other if somehow your two horizons can overlap. And we don't know how to do that in our universe because they're non-causal. You'd have to find some way to tunnel from one universe to the other in order to access that, but that could be very dangerous. Because if the laws of physics are different than the ones you evolved on, then you could just dissolve into a pile of goo because the charge on the electron is different and all of your biochemistry would change.
The multiverse is a hypothetical group of multiple universes. Together, these universes comprise everything that exists, the entirety of space, time, matter, energy, information, and the physical laws and constants that describe them. The different universes within the multiverse are called parallel universes, alternate universes, or many worlds. In pop culture, they are known as parallel dimensions, quantum realities, alternate realities, etc. The physics community has debated the various multiverse theories over time. Prominent physicists are divided about whether other universes exist outside of our own. Some physicists say the multiverse is not a legitimate topic of scientific inquiry. Concerns have been raised about whether attempts to exempt the multiverse from experimental verification could erode public confidence in science and ultimately damage the study of fundamental physics. Some have argued that the multiverse is a philosophical notion rather than a scientific hypothesis because it cannot be empirically falsified. The ability to disprove a theory by means of scientific experiment has always been part of the accepted scientific method. Nobel laureate Steve Weinberg suggested that if the multiverse existed, the hope of finding a rational explanation for the precise values of quark masses and other constants of the standard model that we observe in our Big Bang is doomed, for their values would be an accident of the particular part of the multiverse in which we live.
There could be a universe where the laws of physics there will never allow matter to coalesce. You'll never get stars. That would be a lifeless universe. There could be another universe where you can make stars, but you don't make heavy elements. That would be a universe with stars, beautiful night skies as we have now, but nothing that we know and love. No planets, no life.
some scientists analyzed the data from the Wilkinson Microwave Anisotropy Probe, an uncrewed spacecraft operating from 2001 to 2010 that measured temperature differences across the sky in cosmic microwave background, the radiant heat emitted from the Big Bang, and claimed they found evidence suggesting that our universe collided with other parallel universes in the distant past. However, a more thorough data analysis from the Wilkinson Microwave Anisotropy Probe and from the Planck satellite, a space observatory operated by the European Space Agency from 2009 to 2013, which mapped the anisotropies of the cosmic microwave background, did not find any statistical significant evidence of universe collisions. There was no evidence of any gravitational pull of other universes on ours either. And to add insult to injury to the proponents that the multiverse hypothesis has been backed up by statistical evidence, the Planck satellite has a resolution 3 times higher than the WMA probe.
In the 1920s, quantum mechanics was invented, discovered, however you want to think scientific advances take place. Quantum mechanics is the study of the small, how particles behave. And we learned that if you get to a small enough scale, you lose the ability to predict with precision the behavior of the system. You can only describe it statistically. And there are ranges of things it can do, and all you can describe is the range of properties that it may have. Well, here's this big grand universe we have described by Einstein's general theory of relativity. But at the Big Bang, the entire universe was the size of an atom. And so you have the need to have the physics of the small, quantum mechanics, marry the physics of the large, general relativity, because they're occupying the same space. Now, when you take quantum mechanics and apply it to aspects of the fabric of space on that scale, what you have is a gurgling of the fabric of space-time. In fact, it's been called a quantum foam. And so now, when you look at this foam, applying the laws of quantum mechanics to it, you realize that this fabric is not limited to one zone or another. In fact, there's a region of the fabric that could hatch out an entire universe with the variations in the laws of physics simply because the conditions that would spawn the laws of physics had variation in them. And so the multiverse is not just some invention out of the ether. It flows out of an application of quantum mechanics to general relativity.
Prominent scientists such as Max Tegmark and Brian Greene have devised classification schemes for the various theoretical types of multiverses and universes that they might comprise. Max Tegmark has provided a taxonomy of 4 levels of universe beyond the familiar observable universe. Level 1 is an extension of our universe. A prediction of cosmic inflation is the existence of an infinite ergodic universe, which, being infinite, must contain Hubble volumes realizing all initial conditions. Level 2 are universes with different physical constants. In the internal inflation theory, the multiverse or space as a whole is stretching and will continue doing so forever. But some regions of space stop stretching and form distinct bubbles that are embryonic level 1 multiverses. Level 3 is the many worlds interpretation of quantum mechanics. One aspect of quantum mechanics is that certain observations cannot be predicted absolutely. Instead, there is a range of possible observations, each with a different probability. According to the many worlds interpretation, each of these possible observations corresponds to a different universe. Level 4 is an ultimate ensemble. The ultimate mathematical universe hypothesis is Tegmark's own hypothesis. This level considers all universes to be equally real, which can be described by different mathematical structures. Tegmark remarks that abstract mathematics is so general that any theory of everything which is definable in purely formal terms, independent of vague human terminology, is also a mathematical structure. He argues this implies that any conceivable parallel universe theory can be described at level 4 and subsumes all other ensembles. Therefore, this level brings closure to the hierarchy of multiverses, and there cannot be a level 5. The American theoretical physicist Brian Greene discussed 9 types of multiverses, but we will discuss them in another video. Enough head scratching for today. Thanks for watching. Did you like this video? Then show your support by liking, subscribing, and ringing the bell to never miss videos like this.